Hi everyone, it's Michael. So let's do a lab walkthrough on creating Lambda function using the AWS SDK for Python. So for lab overview and objectives, in this lab, you will use the AWS SDK for Python Boto 3 to create AWS Lambda functions. Call to the REST API that you created in the earlier Amazon API Gateway lab will initiate the functions. One of the Lambda functions will perform either an Amazon DynamoDB database table scan or an index scan. Another Lambda function will return a standard acknowledgement message that you will enhance later in the lab where implement Amazon Cognito. After completing this lab, you should be able to create a Lambda function that queries a DynamoDB database table, grants sufficient permissions to a Lambda function so that it can read data from DynamoDB. Configure REST API methods to invoke Lambda functions using Amazon API Gateway. So here's the scenario. The cafe is eager to launch a dynamic version of their website so that the website can access data stored in the database. Sophia has been making steady progress toward this goal. In the previous lab, you played the role of Sophia and created a DynamoDB database. The database table contains cafe menu details, and an index holds menu items that are flagged as specials. Then in another lab, you created an API to add the ability for the website to receive mock data through a REST API calls. In this lab, you will again play the role of Sophia. You will replace the mock endpoints with functional endpoints so that their web application can connect to the database. You will use Lambda to bridge the connection between the GET APIs and the data stored in DynamoDB. Finally, for the POST API call, Lambda will return an updated acknowledgement message. Now, let's go to task 1, configuring the development environment. In this first task, you will configure your AWS Cloud 9 environment so that you can create Lambda functions. Connect to the AWS Cloud 9 Integrated Development Environment IDE. So from the Services menu, we go to search for and select Cloud 9. So notice the existing IDE, which is named Cloud9 Instance. For that IDE, choose Open. The AWS Cloud9 IDE loads in a new browser tab. So download and extract the files that you will need for this lab. In the same terminal, we're going to run this command right here. Let this finally okay, so it's finally loaded. So I'm going to run this code right here to download our necessary resources. Now the code .zip file is downloaded to the AWS Cloud9 instance. The file is listed in the left navigation panel right here, code.zip. So what we need to do is unzip this file by type in unzip code.zip. So we unzip the file now. Now run the script that recreates the work that you completed in the earlier labs into this AWS account. Note this script populates the Amazon's simple storage service Amazon S3 bucket with the cafe website code and configures the bucket policy as you did in the Amazon S3 lab. The script also creates a DynamoDB table and populates it with data as you did in the DynamoDB lab. Finally, the script recreates the REST API that you created in the API Gateway lab. To set permission on the script, then run it. We're going to run the following command right here in the terminal. Okay. So when prompted for an IP address, enter the IPv4 address that the internet uses to contact your computer. You can find this IP address from this website right here. Note that the IPv4 address that you will set will be used in the bucket policies. Only requests that originate from the IPv4 address that you identify will be allowed to load the website pages. Do not set it to 000 because the S3 bucket block public access setting will block this address. So we're going to use this IP address right here. Okay. It's still running. Okay, so we're just going to wait until it's finished downloading everything. Okay, so we enter our IP address that I just copied. Enter. Okay, it's done. So this is what we want to do. We go back, and to verify the SDK for Python is installed, run the following command in the AWS Cloud9 terminal. So it is verified. So if there is a message about not using the latest version of pip, we can ignore this message, but we don't receive that. Now take a moment to see what resources the script created. So confirm that an S3 bucket is hosting the cafe website's files, right? So in your environment browser tab, browse to the Amazon S3 console and choose the name of the bucket that was created. So I'm going here. I'm going to create a new tab. I'm looking for S3. I'm going to try to find the S3 bucket that's just created. It's still loading. So this is the S3 bucket that's just created. Okay. Choose the index.html and copy the object's URL. So go in here, index.html, and we need to copy the object URL. So this is the object URL right here. So load the URL in the new browser tab. So I want to load it in here in the new browser tab. So we have so this is XML file does not appear to have any start information associated with it. The document trees is so like below. Okay. So the cafe website display. Currently, the website is accessing the hard-coded menu data that is stored in the S3 to display the menu information. Notice that several menu items are listed in the browse pastures section of the page. Then confirm. Choose this. Okay. So confirm that we're gonna load this. Yes. This is what we load right here. So this is what we get for now. So confirm that DynamoDB has the menu data stored in the table. So browse to DynamoDB consoles. Okay. So we're going to choose tab and choose food product table. Go to table and choose food products table. Now explore the table item and confirm that the table is populated with menu data. Let's see. This is table. Is populated with anything. Explore table. Okay, so here's our data. It's good. Explore the table items and confirm that the table is populated with menu data. Yes. So choose view table details. All right. And then other indexes tab. Confirm that the index name special GSI was created. Yes, it is. Confirm that the product API REST API was defined in the API gateway. So browse the API gateway console. Let me open a new tab. Go browse here, go to API gateway, and then choose the name of the product API. Okay, product API. The API has a get method for product and a get method for product on offer. Okay, get product and get product on offer. So finally, the API has posed an options method for create report. Yes, it does. You can use the test button for each method to ensure that they are running the mock data that you are used in the previous lab. Each method should return a 200 HTML status code. This one, let's see. I will test it. All right, 200, nice. 200 status, which is nice. So we need to see. Awesome, very good. So now copy the invoke URL for the API to your clipboard. So in the API gateway console, on the left panel, we're going to choose stages. So go to stages and then choose the prod stage right here. Yes. Note if you see a warning that you do not have list web ACL and associate web ACL permission, ignore the warning. Copy the invoke URL values that display at the top of the page. You will use this value in the next step. Invoke URL right here. So update the website's config.js file in the AWS Cloud9 IDE browser tab. Open this resource websites config.js. Resource websites config.js. All right. On line 2, replace no with the invoke URL. Line 2. Replace that URL. Oh, I believe it needs to be a string. So turn it into a string, right? Be sure to surround URL in double quotation mark. All right, so it's double quotation mark. All right, so this is the one. On line 2, replace that. So with the invoke URL value that you copied a moment ago, also be sure to surround the URL in the double quotation mark. Okay, so the file now look like the following example, but you will have a different value for some value. Verify that prod appears at the end of the URL with no trailing slash. Good. Save the change to the file. Come here, file, save it. Awesome, it's saved. Now update and then run the update config script. So open Python updates config.py in the text editor. So Python 3, right? So we have updates config right here. So replace the FMI1 placeholder with the name of your bucket. To find the bucket name in the S3 console, run the following command: AWS S3 ls. AWS S3 ls. Go to give the name of our bucket. So our bucket name should be this one right here. Okay. So we replace that FI1 with the bucket's name. All right. Let's see. Notice that this script will upload the config.js files that you just edited to the SD bucket. Save the change to the file. Now to run the script, run the following right here. Alright, which change directory to Python 3. Then we're going to run the update config Python 5. So it is done. Good. Awesome. Load the latest Cafe websites with the developer console's view exposed. If you still have the Cafe websites open in the browser tab, return to it. If you do not have the websites open, reopen it now by following the steps. Let's see if we have this. Nope, it's not this one right here. Let's go back. In the Amazon S3 console, which was the name of the bucket, contained the websites 5. Amazon S3, what is it? Right here. Go to Amazon S3, go to bucket, right? Okay, so I choose this bucket right here, that's the only one, and then go to index.html and then copy the object URL value right here, and then I want to paste it here. So there's some errors. It's not display, but we did configure all the steps. Maybe this, just search this one. Object URL. Load the object URL. It's tell it to load the object URL, but it doesn't. Okay. Somehow it doesn't work right now. But we did all the steps, so let's go back. Load it. Refresh the browser tab to load the changes to the Cafe website displays. Observe the browser history section of the website. Notice that only one item menu are now displayed. This indicates that you are no longer viewing the hard-coded data. Instead, the websites return the mock data just as you configure it to do the previous lab. Your AWS account is now configured as shows in the following diagram right here. So this is our diagram. Okay. So by the end of this lab, you will have created Lambda function that the API will invoke. At this point, your account resources and configuration will look like something in the following diagram right here. Okay. So task 2, create a Lambda function to retrieve data from the DynamoDB. So first, Lambda function that you create will respond to any product get request from the website. The function will replace the mock endpoints that you create for the product API resource in the previous lab. So observe and edit the Python code that you will use in the Lambda function. So in the AWS Cloud 9.5 browser, let me open a new tab again. Go to S3, click it. HTML, index.html, click into this. Still doesn't work, doesn't matter. So we're just going to complete all the task. Okay, so observe and edit the Python code that you will use in Lambda function. So AWS, in the AWS Cloud 9.5 browser open, Python 3 get our product code. Right here, Python 3. Inside Python 3, you're going to get our products code. Get our product code. Now we're going to replace the fmi1 placeholder and fm2 placeholder with proper values. To find the missing value in the code, return to DynamoDB console. Notice that the code does the following. It's create the Boto3 client to interact with the DynamoDB service. It reads the item out of the table and return the menu data. It's also scan the table, index, and filter for items that are in stock. Okay. So we're going to find the table name string. Let's go find that. So in order to do that, we have to go to DynamoDB console right here. We'll go to our table. The first thing is we need to look for the table names. To our table, product name string. So this is the name of the table right here, right? So I'll change that name in here. All right. So the next one is what we need to do. This one is right here. The next one, index name. What is the index name of this? Let's go here. Go to index. What is the index name? It's right here. Say index name str. Index names must be this one. Special GSI. So I put it here. Save it. Save. Awesome. So test the code locally. To ensure that you are in the correct folder, we're going to change directory to Python 3, which are in, and then we're going to run this code locally. Awesome. To get us back the table object. If you run the code successfully, the first part of the table data is returned in the terminal output formatted adjacent document as shows below right here. Awesome. So modify a setting in the code and test it again. So in the get our products code 5, Lightail has its following code right here. So analysis is if the alpha path string available is not found, the condition fail and run a scan of the table. To verify that this logic is working temporarily, reverses conditions to remove the word not from this line code. So that is look like so. Okay. So if I go to line 12 and if I change this like that, all right, and then run this code again, it's will not work. All right. So let's change this back. Oh, I didn't save it, so I have to save it first to see if so that it's not work. All right. Or it's working as a different other way around. Okay. And now save it again. Okay, so our data is different. Awesome. Save the changes. So verify that this logic works. Save changes. Okay, this is what we just did, and this is what we get. Okay. Notice the field menu item were returned this time, and this was intended result. The website call to the REST API will implement the code so the customer can filter the menu for on item menu. So yeah, let's change this back, save it. So this filter our menu. Okay. So now that you know that the logic, how the logic works, reserve the order, change and define the Lambda function, run the code. Now reserve the changes that you made in the code. So on line 2, add the work not back to the code again, so it's going to read as following. Okay, so I just keep. Okay, let's save it again and then run the code. Awesome. So that's what it tells us to do. So comment out the last line in the code and save the file. So to comment out the last line, we're going to use a hashtag. The last should look like something following right here. This is last line. Put a hashtag in here. Wait, hashtag right here. Awesome. I'm just going to save it. Locate the IAM row that the Lambda functions will use, and then copy the row ARN Amazon resource number ARN values. So browse to the IAM consoles and choose rows. And go to IAM. Boom. So now we choose rows. It is just box search for and select the Lambda access to DynamoDB row that has been created for you. Which one is it? Oh, Lambda access to DynamoDB right here. Lambda access to DynamoDB. So I'm going to choose that one. All right. Notice that this row provides read-only access to DynamoDB. All right. The policy provides enough access for Lambda to read the data that is stored in DynamoDB. Copy the row ARN values. All right. You will use this for the next step. So edit the wrapper code that you will use to create the Lambda function. So return to the AWS Cloud9 file browser right here, and I'm going to go to browse to the Python 3 get all products wrapper. Python 3 get all products wrapper. Awesome. And on line 5, we replace the right here with the row ARN values that you just copy. To change row right here. Awesome. I want to save it. Save change to 5. Observe what the get all products wrapper code will accomplish when it is run to create a Lambda model 3 clients, right? And set the name of the row that the Lambda function should use. Reference the location of the S3 bucket that has the code that the Lambda function should run. The code you just zip and place in the Amazon S3. Uses all of this information to create the Lambda function. The function definition identifies Python.3.8 as the runtime. So package the code and store it in S3 buckets. So a bucket with the S3 bucket in the name was created for you when you started the lab. Verify that the AWS Cloud9 terminal is in the Python 3. It is. Yes, it is. To place a copy of your code in a zip file, run the following command right here. Okay. Next, retrieve the name of your S3 buckets by running the following command here. Outcomes. Awesome. Finally, replace the zip file in the buckets, running the following command and replace it with the actual bucket name. Alright. So that's what I'm going to do. I will copy the bucket name right here. Alright. And then go back. Go back in here. Paste this in here. Awesome. Verify that the command succeeded. The response looks like the following. All right. Yep, it is. To create the Lambda function, run the following command right here. Run it. Okay, this is done. The output of the command should be done, confirming that the code ran without any errors. Observe the function that you created and test it. So browse the Lambda console, choose the name of get all products function that you just created. Wait, observe the function that you just created and test it. So choose the Lambda consoles. Lambda. Let's go back. Go to Lambda. Get our product that I just created. Okay. Choose test. No test option. Oh, test right here. So I test it. All right, success. For the event name, enter products. Event names, choose product. Keep all of the other default test event values and choose save. All right, save everything. Choose test again. Where is it? Okay, test again. Awesome. The tabs that show the result of your test display with response that shows the data returned from the DynamoDB table. The following example right here. Alright. Yep, this is what we have. Product item array. So create a new test event that's called on offer. So in the code source panel, open test menu. In the code source panel, is it in here? Code source panel doesn't see that. So that is the case. I'm gonna open a new tab, find code source. This is not here. Open the test menu, configure test event. So in the code source panel, open test menu. Code source right here. Oh, right here, code source. And then open the test menu. Alright, open test menu, choose icon, choose configure test event. Configure test event right here. Awesome. So choose the create new event. Create new event. And then for the event's name, it's going to be on offer. Alright. And then in the code editor panel, we're going to replace the existing code with the following right here. Alright. Now we're going to choose save. Awesome. Now we're going to choose test. And this is what we got back as response. This time the result only displays the item that are on the offer but not out of stock. So scroll to the bottom of the test result to the functions logs. You will see the message running scan on index. Right. Running scan on index right here. Awesome. As you can see, your Lambda function is now successfully retrieving data from the DynamoDB table. You have also observed that this one Lambda function can be used to return all menu items or only the ones that are on offer. Congratulations on achieving this milestone. The next step is to configure the REST API to invoke this Lambda function whenever anyone requests product data on the website. You will also need to find a way to pass the path variable to Lambda when customers choose to view only on offer products. Task 3, configuring the REST API to invoke the Lambda function. First, you tested the code locally in AWS Cloud9 to ensure that it worked. Then you deploy the code as a Lambda functions and tested that it worked as deployed. In this task, you will configure the product and product on offer REST API functions to invoke the get all products Lambda functions so that the code can be invoked from the cafe website. Test the existing get product resource browse to the API gateway console. API gateway console. So we going to choose the product API, okay, and choose get method for the / product. All right. Notice that on the right side of the page that the method is still accessing the mock endpoints. So we're going to choose test and then choose test at the end of the bottom of the page. Test and then test again. So this is what we get. Awesome. So we verify that response body correctly returned the mock data right here. Okay. Replace the mock endpoint with the Lambda function. So at the top of the page, ensure that get method is still selected under the product. Choose integrations, requests, and edit. We will choose integration request right here, and edit. So inside integration request edit, in integration type should be Lambda function right here. And then the Lambda region should be US East 1. US East 1 right here. The Lambda function is going to be get our product. Choose the Lambda functions. Get our product right here. There's only one available. So now we're going to choose save. It is saved now. Notice that on the right side of the page that the method is no longer called mock endpoints. Instead, it is calling your Lambda functions. Right here, Lambda function. Nice. Right here. Okay, so what we need to do is test the product get API call one more time by selecting test. Okay. The return call, the return output similar to the following right here. So let's test it. So it is what it's getting right here. Awesome. Analyze the results. So when you switch the integration endpoint from the mock endpoint to the Lambda function, the response headers that they permitted across origins resource sharing clause were removed. If you scroll down past the response data, the response header section now show only the following right here. Okay, so let's see the content type. Right, so this is what we have. Okay, awesome. Let's go back. The response header does not contain the course information that you needed because the API gateway reside in a different subdomain. US East 1 Amazon.com, then the S3 buckets. You could manually add the course configuration back to this resource using the AWS SDK. However, API gateway has a feature that makes it simple to permit course. Now, re-enable course on the product API resource. So we're going to choose product so that it is highlighted and select get method. Product, get. Select the get method. Let's see. Select default for XX under gateway response. Gateway response. Alrighty, what we need to do. So choose / product, so it's highlighted. Select get method. Select this under the gateway response. Let's see where is the gateway response. Alright, so in the gateway response, we're going to select default for XX. gateway response right here. So we're going to select this one. Select get under the access control. Select get under the access controls allow methods. Alright, what do we need to do here? Select get under access control allow methods. Access control allow methods. Access control allows methods. Does that mean I have to edit in here? Oh, what is going on here? So it's going to say to choose the product so that it is highlighted, right? Let's go back. Go to API. Choose product API. Go in here. Select get. Alright. Now select product, not get. Select product. Select the get method. This is a get method. We're just going to select it. Okay. And then select get method under select the defaults for exit defaults for XX under gateway response. Integration response. There's only integration response when where is gateway response? Default response, method response. Okay. This is request. Very interesting. It looks like maybe the GUI is changed, so maybe the option is now to accomplish these steps we have to take different approach. Method response test. Alright, so let's say I'm going to gateway response, right? I'm going to choose default for XX, default for X. Select get under access, alright. Select get under access control allow method. Alright, doesn't look like it has that. So maybe we just want to choose get method for products and then choose test. Go back, go here, products, get, and go to test it. Let's see. This is what we get. Scroll down to the response header section again. This time, access control change allow. Let's see. Everything so right here, interesting. So how are we going to do this? Interesting. Let's see. Let's go back. Where are we right now? Right here. Re-enable calls on the product API resource. This is our resources, alright? We go to products. I will go to Oh, right here, enable calls. Huh. Oh, this is how we do it. Okay, under gateway response right here, and then select get under access control allow method, and then choose save. Okay, so that's how it is. Awesome. And then choose a get method for the products. Okay, and then test it. And then we're going to look for this. Yep, it is allow. Nice. Access control allow. Origins allow. So here's the following. So following is example of the output. Your data will have the different value for the root. Okay. Awesome. This work. So using the same approach, we're going to update the on offer get API method. So we're going to choose the product API. Okay, so let's go back to our API, product API, and then choose get method for the on offer. Get method from the on offer. Okay. Choose integration requests and configure. Integration requests. Integration. So where's the integration request? Right here, and then we configure integration request. Integration types to be Lambda function, and Lambda region to be US East 1. And then for the Lambda function, it's going to be this name right here, which is get our products. Then we're going to choose save. Very good. Now we'll select default under the gateway response. So where is it? This one? Nope. Integrations. Oh, not this one. Go back. Save. So choose on offer that's highlighted. Enable calls. Integration requests. Integration requests. Response. Not this one. Oh, we should test, right? Test that one. Was calls enabled on this one. Test it. Not the R products. Enable calls. Not yet. Where did I get that things? So right here, maybe go to edit. Oh, this seems like to be this one. Where am I now? Okay, so choose save and now choose on offer. So that is highlighted. Enable calls. Choose enable calls. Save. Save and choose on offer. Oh, right here, enable course. So it had to be on top of it. Choose enable course and choose default for x and 5x, and then under the gateway response, then select get under the access control allow methods, and then save. Nice. Very nice. So we're going to test on the on offer API call. So choose the get method for the products on offer right here. Okay. Now we're going to choose test. And then test it. The Lambda function is returning all the menu. Okay, no. Let's see. Test it. Let's scroll down to the response header. Notice the course is enabled in the header. Right here. It's allow. Okay. Scroll back to the respond body section. Do you notice an issue? The Lambda function is returning all the menu item, not just the specials. This is because the conditional checks on offer string not working. So recall the relevant code right here. Analysis. You need to set an API logic for the product on offer to pass the path to the event object that Lambda used. The next step explain how to do that. Okay, so configure the on offer integration request details. We're going to choose get method for the product on offer. So right here, we're in the product and on offer right here. Choose integration request. Right. Choose the get method for the product on offer. Okay. Choose, and then after that, choose integration request. Okay. Choose edit. Expand the mapping template. Mapping template right here. In the context type box, enter the following text. Content type box. Good. Under the generate code, generate template, choose method request pass to. Replace the text with the following. All right. Oh, I guess I have to keep it as it is. Alrighty. This will evaluate the product on offer. For now, the code simply check for existing of the variable. Choose save at the bottom. Good. So what we're to do now is we're going to test the get method for the on offer again. Okay. Verify that only the offer item, 6 items are returned. Yep. 1, 2, 3, 4, 5, 6. Alright, it's about 6 items. It's much less than compared to its use before. So excellent. Now that this offer this filter is working, you can deploy the API. Deploy API. So in the resource panel, choose API route. Oh, where is it? Oh, right here. This is the API route. Choose deploy API. For the deployment stage, choose prod. All right, and then choose deploy. Cool. So deploy successfully. Congratulations, you have successfully updated the REST API so that it invokes a single Lambda function that can now filter for offer items. With this logic, you do not need to create and maintain two separate Lambda functions to handle this functionality. So, task 4 is creating a Lambda function for report a request in the future. In this task, you will create complete steps that are similar to what you just did. However, this time you will create a Lambda function for the create report post actions. So observe the test and test the Python code that you will use in the Lambda functions. Back in the AWS Cloud9 IDE, browse to and open Python 3 create report code. So go to Cloud 3. We go to create report code. Create report code right here. Right. Awesome. Report code. Notice that this code does not do much yet. It simply returns the message. In the later lab, you will implement more useful logic to actually create a report. However, this code will suffice for now. Run the following code command in the terminal. Let's run it. And then there's some error. Is it error? No, this is not an error. It's a string report processing. Check your phone shortly. Oh. Okay. So the output returned in the terminals is this, which is what we have. Notice that the capitalized R, right? Capitalized R. In the word report, I see. The mock data contains the lowercase r instead. This difference is how you can know that the website is accessing the Lambda function and not the mock data. Comment out the last line of the code in the create report code. To comment out the last line, use the hashtag like this. Alright, with the last slide right here. Using hashtag lines to comment that out and save it. Alright. Edit the wrapper codes that you will use to create the Lambda function. So browse to and open the Python 3 create report wrapper. Python 3 create report wrapper. Nice. On line 5, replace the FMI placeholder with the Lambda access to DynamoDB row IAM values. You might need to return to the IAM consoles to copy the row AMI. Okay. Identity access management. All right. Where is it? The first thing first. What we need. The first one is row. What is row? We're going to choose a row ARN, which is this. Where is it? Cloud9 Lambda. This one's right here. This is a ARN of that one. So this is what we need. Go back here. Our row is going to be this value right here. Only FMI online fine sounds good. So what I'm going to do is I want to save it now. Good. Notice you may need to return to let's save it. Awesome. Package the code and store it in the S3 bucket. So to place a copy of your code in a zip file, run the following commands right here. So we're going to run zip create a report code, create report code. Awesome. It is good. So to place the zip file in the bucket, run the following command right here. Replace the bucket with name with actual bucket name. AWS S3LS going to give us a bucket name. Awesome. So we're going to run this command right here, and then we're going to choose our bucket name. And then we're going to run it right here. Awesome. It is ran, uploaded. So verify the command successful. The following is output. It's right here. Awesome. Finally, to create the Lambda functions, we're going to run the following command right here. Nice, this is done. Observe the create report function that you create and test it. Browse the Lambda consoles. Right. We're going to browse the Lambda console. Go to Lambda. Now we're going to choose the name of the create report function that you just created. Create report. Right here. On the consoles panel, open the double click the create report code.py. Source panel must be right here. Choose the create report code. Where is it? Create report code. Create report code right here. To display the code. To test. Oh no, it's not that one. Where are we right now? Is it in here? It's in here. There's a console panel right here. Alright. Choose test. For the event's name, choose report test. Nope. Alright. Keep all of the other default test event values and then choose save. The test event is safe. Now choose test again. Awesome, this is what we have. Nice. Notice the capitalized R instead of the lowercase r that is used in the mock data. Therefore, you know that the website is accessing the Lambda functions and not the mock data. Now, task 5, configuring the REST API to invoke the Lambda function to handle reports. Recall that in the previous task, you configured both get methods in your API to invoke the first Lambda function that you created. In this task, you will complete the similar step to configure the post method in the API to invoke the new create report Lambda functions. So, test the existing post method for the create report. So, browse the API gateway consoles, API gateway. Is a API gateway. Now we're going to choose a product API. We're going to choose product API here, and then choose the post method for the create a report. This is create report. Choose a post method. Notice on the right side of the page that the method is still accessing mock endpoints right here. Choose test and then choose test at the bottom of the page. Now test it. This is what we have. Lowercase r, which is mean this is still using mock endpoint. Replace the mock endpoint with the Lambda function, so ensure that the post method is still selected. Post method, yep, it's still selected. So now we're going to choose integration requests, and then choose edit. Types will be Lambda functions. Region should be US1 right here, and then for the Lambda functions should be this. What is it? This will be create report. Now we're going to choose save. Notice on the right side of the panel of the page that the post method is no longer calling a mock endpoint. Instead, it is calling the Lambda functions right here. Awesome. Now, if we go to test it again. Awesome. Now we notice the uppercase R, meaning is using the actual endpoint now. Alrighty, notice that you could configure the calls on this method as you did for other API method. However, you do not need to because the website will not invoke the URL until the later lab when you enable authentication. So deploy API. So in the resources panel, right? In the resources panel, choose the root API. Okay, and then choose deploy API. For this stage, choose prod, and then choose deploy. Nice, awesome, successfully deployed it. So congratulations, you have successfully updated the REST API so that it invokes the create report Lambda function. Now task 6 is testing the integration using the cafe website. So in this final task, you will test both API call product and product on offer to the website. So load the website, return to the browser tab where you have the cafe website open, refresh the page. So to find the page again, so basically just go to S3 consoles. Can go here, go to S3 console, and then just choose our buckets, right? Where's our bucket right here? So we go here, then go to index.html, so object URL. Somehow this is not working right here, but like we have set everything correctly. So for the fake website display, the website is now accessing the data here. Now to test the menu, we're just gonna scroll down and everything, view all the verify that the menu has returned everything. We can edit the menu. We can edit the menu item in the price in the DynamoDB table and verify that the change is reflected on the websites. Select the favorite offer and things like that. So basically to interact with the website when it's loaded. So update from the cafe. So Sophia is satisfied that she has made progress. Her plan is to build a serverless dynamic website with the database backend is really coming to fruition. Sophia's initial plan had 3 major milestones. The first milestone was to create the database backend to store cafe data. She accomplished that in the DynamoDB labs. The second milestone was to create the REST API so that the web page hosted on the Amazon S3 could interact with mock data. She completed most difficult part of the task during the API gateway lab. The third milestone was to create a Lambda function to create the DynamoDB table or index or return a static message, and then to update the REST API resources to initiate the respective Lambda functions. You acted as Sophia. I have now built all of these resources in the lab up to this point in the course. The following diagram shows the architecture that you have built right here. So Sophia knows that she has more work to do. For example, she needs to add authentication so that login user can leverage a create report API and generate reports, and that will be implemented behind the login button that appear at the top of the website. Sophia also just heard from the cafe owner that they are in the final stage of acquiring another company, a coffee bean supplier. The acquisition will probably create additional requirements but for now though, Sophia decides to celebrate her most recent accomplishment by relaxing with her friends. Awesome, so that is pretty much it for this lab. Thank you so much for watching and have a great day. Bye bye.